Number 39. Some incandescent light bulbs are filled with argon gas. What is the root mean square velocity for argon atoms near the filament, assuming their temperature is 2500 Kelvin? All right, so basically we need to know the relationship between root mean square velocity and temperature. So I have in a prior video, it's titled Kinetic Theory of Gases. I derived this formula in there. Don't be worried about the word derived. I know it sounds scary, but it's not, all right? I'm going to write that formula down. If you want to know how this formula came about, please reference that video. All right, so we have the root mean square velocity will then be equal to the square root of 3kT all over m, where K is the Boltzmann constant, T is the temperature of the gas in Kelvin, and then m represents the mass of a molecule or atom, depending upon what we're talking about, okay? So basically, I know the temperature, that's simple. Here, they give it to me. But do we know the mass? No, we do not know the mass, right? Oh, and by the way, to that video, there'll be a link in the description. Sorry. Okay, so we don't know the mass of the argon atom, okay? A single argon atom, that's what we need. Well, what do we know about it? Now, I mean, you might be able to look it up on Google, but I'm going to assume that you don't have that ability. I mean, not that you can't Google it. I'm sure you can type it in, and I'm sure you don't have a problem Googling that. I just mean on a particular test, you might not have that value handy, but you might be given a periodic table. So when you look argon gas up on a periodic table, you'll see that it says about 40 grams. Argon weighs 40 grams per mole. Okay? Now, I know it says 39.9. Don't go nuts. I'm just rounding here. So what we have to do is we have to figure out then the mass, remember, has to be in kilograms, right? Mass is always in kilograms here in physics. So we have to convert this basically into kilograms per atom, okay? That's the goal here, all right? So what I need to do, and that's really the crux of the problem, so we got to do 40 grams per mole and somehow convert that into kilogram per atom. So we deal with each unit basically at this independently, right? So we're going to do 40 grams per how many moles? Per 1 mole. Remember, anytime it's per anything, it's always per one of that anything. So what we're now going to do is we're now going to multiply then grams on the bottom, kilogram on the top. You know that there's 1,000 grams in 1 kilogram. So see you later, gram. My answer right now would be then kilogram per mole if I were to stop. But I don't want kilogram per mole, I want kilogram per atom. So what I need to do is get rid of then the moles on the bottom and replace this term with atoms. So if you want to cancel the mole, and it is on the bottom here, where must you place the mole in your conversion factor over here? On the top, right? Not on the bottom. Why? Because it has to be on opposite sides, okay? So now we need to think, well, can I go from mole to atom? Do I know a relationship between the two? And you should. Right? If you've taken chemistry, this should be familiar. And if you haven't taken chemistry, I don't know. Yeah, sure. Should still be familiar. If you haven't taken chemistry, it might be, I don't know what's going on. It might be less familiar, but you may have seen it in class or whatnot, or I might have discussed it already. Actually, I think I did discuss it in one of the prior video. I think on ideal gases, I put a note at the bottom. So 6.02 times 10 to the 23rd. This is just a conversion. There is this many atoms in a mole. Okay? You could also substitute the word molecule here, but why is that the case? Because remember, a mole is just a collection of things. So if you're talking about argon atoms, 1 mole of argon atoms will be equivalent to 6.02 times 10 to the 23rd atoms of argon. All right. Anyway, not to belabor the point, let's do the calculation. So it's going to be 40 divided now by, in parentheses, 1,000 multiplied then by 6.02 times 10 to the 23rd. And what do we get? Ooh, some tiny value, right? So we get 6.64 times 10 to the negative 26th kilograms. And that's basically kilogram per atom, right? Now that's what we need, okay? When you plug in your units here, you're just going to plug in the kilogram, unit here, but you have to know the mass of a single atom, okay? So that would be the number. Now, literally, the problem's simple. All we got to do is just plug this in. V sub RMS will be equal to a square root of 3 times the Boltzmann constant. That is memorized, 1.38 times 10 to the minus 23. And I don't know what's going on with the pen right now. Multiplied then by the temperature, and they said at 2,500 degrees Kelvin. with 2500 Kelvin, and then divide it then by the mass of a single atom. So 10 to the minus 26. And all we got to simply do is plug it on in to the old handy dandy calculator, right? So square root of 3 times 1.38 times 10 to the minus 23, multiply them by 2500, divide that result by 6.64 times 10 to the minus 26, and here we go. We get a velocity of about, a root mean square of about 1.25, I don't know, 2 sig figs, 3 sig figs, 2 sig figs, whatever. We'll do, I don't know, we'll do 2. So 1.2 times 10 to the 3. And that is in meters per second then. Okay. And voila, there it is. Guys, thanks for tuning in. All right, remember to check out that other video, and I look forward to helping you with more problems. Take care.